What shocking images did Cassini reveal on Saturn? On October 15, 1997, a two-stage Titan IVB Centaur rocket was launched from Cape Canaveral Station, which carried on board one of the most important space exploration projects in history, the Cassini-Huygens space probe. This would take care of studying Saturn and reveal incredible mysteries about this huge gaseous body and its natural satellites. The Cassini-Huygens mission resulted from a collaboration between 3 space agencies and the contribution of 27 countries for development. NASA JPL built a Cassini orbiter. The Huygens probe was built by the European Space Agency ESA, while the Italian Space Agency was tasked with providing Cassini's high-gain communication antenna. The Cassini-Huygens mission was so named because it was divided into 2 stages. On the one hand, the Cassini Space Exploration Probe, which would be responsible for orbiting the planets to collect information from various bodies, and on the other hand, the Huygens Landing Probe, which had the objective of landing on one of Saturn's moons to study its surface. A long journey. Cassini had the mission of studying mainly the planet Saturn. For this, it was necessary to travel a long way that had to be overcome in record time. To reach its destination, the Cassini spacecraft used the flyby of planets to increase its speed and take the final direction towards Saturn. In total, the Cassini spacecraft made 4 flybys, 2 to Venus, 1 to Earth, 1 to Jupiter. During all that time, from launch to several months after flying over our planet, the spacecraft remained oriented with its primary antenna towards the Sun. In this way, the probe was positioned to protect the instruments from heat, since in its second flyby of Venus, the spacecraft approached 90 million kilometers near our star. 55 days after the second flyby of Venus, on August 18th, the spacecraft returned to Earth. It was about 1,000 kilometers away, with a speed of 19 kilometers per second or 68,000 kilometers per hour. This time, 9 instruments from the probe were activated to make some observations of the Earth-Moon system and take incredible photographs of our planet and our natural satellite. Finally, the expected encounter with Jupiter occurred more than 9.7 million kilometers away from the planet. Despite such a distant distance, the spacecraft obtained precious data on Jupiter's atmosphere and other data from the magnetosphere that were of great importance in understanding the influence of Jupiter's magnetic field throughout the solar system. One of the most significant discoveries during the Cassini space probe's journey was that radio waves sent from Earth to Cassini were deflected by the Sun's gravitational field, distorting the time it took for the signals to arrive. This measurement of time change of the signals due to the movement of the Earth and the ship, as well as the action of the gravitational field of the Sun, were helpful in verifying Albert Einstein's theory of relativity, who years ago had predicted this behavior due to the presence of strong gravitational fields. Arrival at Saturn. The Cassini probe reached its destination in June of 2004 and captured incredible images of the planet Saturn, its unique rings, and its mysterious satellites. During its first days orbiting Saturn, Cassini discovered 2 new satellites that had never been seen before, Methone and Pallene, which lie between the orbits of Mimas and Enceladus. Neither of the 2 natural satellites has a spherical shape. That is, they have irregular shapes because Methone and Pallene are small satellites, and their gravitational force is not so great as to give them a spherical shape. Later, on June 11, 2004, Cassini flew over the moon Phoebe, where it managed to corroborate what many scientists believe, and that is this natural satellite is the only one that orbits Saturn in the opposite direction to the rest of the satellites. In addition to the photographs taken by Cassini, show that this moon could have water under its surface. On July 1, 2004, Cassini became the first instrument created by humanity to orbit Saturn, taking the first high-quality images of this gas giant. Thanks to this, we could see this beautiful planet with its enigmatic rings as we had never seen it before. The quality of the images Cassini took was so good that thanks to the photographs, we discovered another ring on Saturn that was impossible to see with conventional telescopes. Titan, Earth's twin? A day after arriving at Saturn, Cassini managed to get close to Titan, the largest satellite of the planet. Images taken from the probe show that Titan's surface looked like Earth's in its early era, as it was arid and with smooth stones throughout the landscape. Titan is the only satellite with a significant atmosphere and the only object other than Earth on which clear evidence of stable liquid bodies had been found on the surface. On December 25, 2005, the Huygens landing probe separated from the Cassini exploration probe to study Titan from within. On January 14, 2005, Huygens managed to land uncomplicated on the surface of Titan, discovering something incredible. Before we could send probes to explore the planets of the solar system, the only way we had to see them was with telescopes. But this had many limitations, especially in those bodies that had very dense and opaque atmospheres that prevented us from seeing their surface like Venus, and of course Titan. The landing of the Huygens probe on Titan helped us discover that this satellite is composed mainly of ice and rocky material and contains lakes of liquid hydrocarbons in the polar regions. Titan's surface is geologically young. Despite the mountains and discovering several possible cryovolcanoes, its surface is smooth with few impact craters, indicating high erosion activity covering the young craters. According to data from the Huygens probe, Titan's atmosphere could be composed mainly of nitrogen, but up to 6% can be methane and complex hydrocarbon compounds. The climate, including wind and rain, creates land-like landforms such as dunes, rivers, lakes, and seas, probably of liquid methane and ethane, and is dominated by seasonal weather patterns as on Earth. With its liquids, both surface and underground, and robust nitrogen atmosphere, Titan's methane cycle closely resembles Earth's water cycle, albeit at a much lower temperature. Knowing this about the satellite, could it be that on Titan there were living beings that have adapted to the conditions of this climate? We don't know, and that is precisely why a project is currently underway by NASA to bring a probe to Titan called Dragonfly, which will move through the satellite. Sadly, due to the pandemic, the launch initially scheduled for 2024 will be delayed 3 years until 2027. Enceladus, another candidate to host life. In 2005, Cassini continued to explore Saturn's moons, and upon encountering the moon, Enceladus discovered it had a weak electromagnetic field and a significant atmosphere with vast layers of ice. It was also possible to observe geysers that released jets of ice particles and water vapor, possibly from an ocean miles deep. Thanks to images taken by the Cassini probe, we now know that cryovolcanoes near Enceladus' south pole eject large amounts of ice into space in the form of geysers and jets of water vapor, other volatile substances, and solid material that includes sodium chloride crystals and ice particles. According to observations, Enceladus' geysers have an ejection rate of up to 200 kilograms per second. To date, more than 100 geysers have been identified in Cassini images, and scientists concluded that some of the geysers' water vapor falls back in the form of snow on the satellite's surface, covering the impact craters, and the rest escapes and supplies most of the material that makes up one of Saturn's rings. In 2014, NASA reported that it had found evidence of the presence of a large subsurface ocean of water at the South Pole, about 10 kilometers thick. That means that there is a possibility that under the kilometers of ice of Enceladus, there are aquatic living beings, giant spots, and hexagonal storms. During its flyby of Saturn on October 25, 2012, the Cassini probe managed to observe the vast, large white spot of Saturn. It is a unique meteorological phenomenon in the solar system. It consists of a storm that reaches practically the size of Earth and is repeated every 30 years. Saturn also possesses one of the most robust storm systems. In 2013, Cassini managed to record a video in high definition of the mysterious hexagonal system of Saturn's North Pole, leaving us with one of the most enigmatic images of the solar system. Today, it's thought that the hexagon of Saturn is formed because, in those areas, there is a high latitudinal gradient in the speed of atmospheric winds. Therefore, although it is located at the pole, it rotates as fast as if it were at the equator of the planet. Cassini's grand finale. In 2017, the Cassini probe had already exhausted almost all of its fuel, and each time its instruments were gradually shutting down. Hence, NASA engineers had to make an important decision, leaving the spacecraft adrift in the hope of recovering it in the future or destroying it. The discoveries Cassini had made indicated that Saturn's satellites were very promising, and some of them could harbor life. If they left it adrift, there was a possibility that sooner or later the probe would crash into one of the moons. Eventually, we would contaminate that place, compromising the chances of finding living beings. So finally, it was decided to destroy the ship the safest way, causing it to crash into Saturn. Remember that Saturn is a gas giant. Because of this, when Cassini enters the atmosphere, it will destroy itself, reducing it to dust due to the high friction with the clouds of the planet. So in April of 2017, after nearly 20 years of incredible research and photography, Cassini began its last journey, making 22 dives through the space between Saturn and its rings. Finally, on September 15, 2017, when Cassini made its last orbit around the planet, it plunged into the dense clouds of Saturn, slowly disintegrating in its atmosphere, this being its great end. Despite this tragic end, during its last seconds of life, the Cassini probe sent us fundamental data about Saturn's clouds that today have helped us better understand how that planet formed. Would you like to see more videos like this where we talk about the contributions of the most important spacecraft in history? Let us know your opinion in the comment section of this video.